keeping score. I am not hitting record. Yeah, so I heard that's a necessary comment, and that's a good question or a statement, because it does not seem like this is useful in any way, shape, or form whatsoever. However, it's incredibly important, right? Because what we do moving forward mathematically and scientifically, guys, if you want to do like a cheer, you can rehearse out in the hall and come back in and do it for everyone. What we do mathematically and scientifically is we try to determine relationships between two different variables. Like, for example, I don't know if you know what the conversion is that goes from Fahrenheit to Celsius in temperature, but there's a formula for that. If you solve it in general terms, if you solve it for F, you'd plug in your Celsius and it'll give you an answer in Fahrenheit. If you solve it for C, you'd plug in your Fahrenheit and it would give you Celsius. So what's the benefit of doing something like that? You can program computers to then give you that information instantaneously. So when you do something like, if you were asking Google, what is 30 degrees Fahrenheit in the Celsius scale, Google is plugging it into the appropriate formula and solving. But it only does that if it has the appropriate formula available. Right? And it's not just limited to Fahrenheit and Celsius. Anytime you have different scales that measure different things, you would want to be able to convert back and forth between them. All right? So metric versus standard units, right? Pounds, kilograms, anything. Miles, kilometers. Right? These are all things that benefit from our ability to solve what we call general equations. So equations that are in general form without having particular values. So it does seem completely arbitrary and useless right now, but it's incredibly important, I promise you, right? So anyway, next step. Divide by 3a. So we're dividing by a 3 and dividing by an a. And so we have x equals, well, just basically what I wrote on the right. Bless you. Not done yet, though. Now there's another excluded value.
Wait, what would it be then? -3. Yeah, 0.
Yeah.
0. But you would put -3 as a.
If I do that, 3 times -3 would give us 0?
-9.
That would give us -9. Well, what I would want to do for this, to figure out the excluded value, very important, if you're not following the concept, take your denominator, 3a, set it equal to 0, and then solve the equation. How would I solve this? Divide by 3. A equals 0 over 3, which is the same as 0. Take your denominator, set it equal to 0, and solve. If you don't see it just by looking at it. And you gotta understand, we're gonna get to a point where sometimes the denominators later on in the course, it's gonna say something like x squared plus 3x plus 4. Figure out the excluded values. So at that point, you're going to have to set it equal to 0 and do some algebra in order to solve it. It's not always going to be the case where you can just look at it and get the answer. All right, so this is a skill that will be necessary for everyone at some point. For now, only for some, but eventually for all. Very well with this. All right, so if my goal here is to solve for the value of x, that's telling me I want to get rid of everything else, right? So what's the first thing I should get rid of? 4. Through what? Multiplication. On the left side, we have a cancellation of the 4's, leaving us with x plus b. And on the right, we have a product of 4 and c. I don't know what c is, so I'm just going to write it as 4c. Subtract b on both sides to get x all by itself.
Oh, I see this now.
It shouldn't be that bad. You would be right in questioning why on earth we need to know this. It's a good question to ask, but there is value in knowing how to manipulate what we call general term equations, right?
Oh, so you try to get rid of the denominator?
Try to get rid of, well, yes, but we generally work in the reverse order of operations, but not always the case. In this case, we want x plus b alone before we do anything else. The way to make that happen would be to multiply both sides by 4. All right. Oh, I did 4 without doing something before it. Nah, one I already have. We'll do 5. Oh, there's a 3. I skipped 3? Okay, that I can do. Oh, no, 3. 3 I already have. Yeah, so I'll do 5. Folks, you gotta understand something. Very important. What I do every day, or what I try to do, is some problems with period 3 and some problems with you. And then I put it all together into one single YouTube video. Right? So what happens is when I say, oh, I already got 3 and I already got 6, it's not like, forget yourselves, you're on your own, figure it out. I don't like you. No, it's more like there's a YouTube video out there with the solutions to that already. Right? You should be able to try those on your own, and then you can check it against the video. Right? What I want to do is unique ones so that period 3 can also benefit, where they get some solutions to problems that we weren't able to go over in class. So a little bit for both groups. All right. But on the next page, if you see a problem or two that you're like, oh, that's extra crispy, we can go over it together. All right, so number 5. First move.
You're going to multiply 5 on both sides.
You could do that, sure.
Isn't adding 7 easier?
Honestly, I think in terms of difficulty, it could amount really to the same thing. If you add 7 and then multiply by 5 as opposed to multiplying by 5 then adding 7, you still have to do some distributing. So in this case here, we're distributing the 5 against each part here. So we're looking at x minus 35 equals 10m.
Why do you distribute to each part then? Yeah.
Because we're multiplying everything by 5 in order to clear out that denominator.
So even though the 5 cancels out with the 5 under x, you still distribute it to the 7.
Yeah, because this is really equivalent. If we're multiplying both sides by 5, it's really the same as saying it like this. Yeah, you can't just multiply, and this is really important algebraic misconception that people have. You can't just multiply whatever parts of an equation you want by a number. If you're going to multiply, you got to multiply every part by that number. All right, so you can't just pick and choose. All right, here I want the 5 to go to everything. Now I want to get the x alone. The only thing left to do would be to subtract off the 35, or sorry, add the 35. Now these aren't like terms, so I can't actually add them together unless I knew what the value of m was. So this is as far as I can go.
Can we do 6?
I already had that. All right, so the other suggestion on number 5 was to add 7 first. So let's see if that ends up being easier. Maybe you like doing it that way more. So add 7 first. X over 5 equals 2m plus 7. Then what? Multiply both sides by 5. So on the left, it's just an x. On the right, you can multiply through with the 5 if you want, or you can just leave it as 5 parentheses 2m plus 7. But ultimately, they amount to the same thing. So get a leg up on it. The question was to go over number 8. It said solve for s. All right, so I want to get s alone. Looks like, I don't even know what to do. opposite operations. If I have addition, I subtract to cancel out the addition. If I have multiplication, I divide. If I have a power of 2, I square root.
Goes S equals A.
Close.
Oh.
So square root of A, but what we're going to do is we're going to put a little plus or minus symbol in front. All right, because it might be a positive measure, it might be a negative measure, right? Now, we do that as a mathematical rule, and then we look at the context and decide, do I need the negative? Do I need the positive? We go from there. It's a good habit to build because it always keeps it in the front of your mind that a negative is a possibility, right? And the idea would be that if I had something like, I don't know, I'll just come up with a relationship. Let's say 4 equals 2 squared. And I wanted to get rid of that power of 2. I take the square root, right? That would give me a 2 equals a 2. So in this case, I'd want a positive. But what if I had 4 equal to negative 2 squared? Still a true statement, right? Negative 2 to the second power is still 4. When I take the square root, the power and the root would cancel out, giving me just a negative 2. But then if I take the square root of 4 here and I wrote positive 2, I'd be wrong, right? I'd have to put a negative here in order for it to be correct. So sometimes it's positive, sometimes it's negative. We account for the possibility that it could be either or, but then we look at the context. So in this case, we're done. This is our final answer. But, because all we had to do is solve for S. Now here's the issue. If this is a geometry situation, then I would only go with the positive. Because the length of a side in geometry, you know, if I take the length of a side of a square, rectangle, triangle, trapezoid, semicircle, whatever, we would only expect positive numbers, right? I don't see any negatives on this. I don't know, maybe it's a shot. They could be there. But so if it's a contextual situation, if we're talking about geometry, then we would only go with the positive. But here it's just letters without any context provided. But if you know that that A stands for area and that S stands for a side, then you would know that we're only looking for positive values. At least until you get to calculus, in which case we start talking about negative sides and negative area. It's just a mess with you, right? But for now, look at the situation. Because sometimes it'll be in the form of a word problem. It'll say, given the formula for the area of a square, A equals S squared, solve for S. Now you need to know that it's positive. But if I were to say, y equals x squared, solve for x, then it could be either positive or negative. All right? So it depends on the situation. Context is very important. And it's something that we're going to be constantly working on throughout the year. Never not going to be working on it. All right. Did you see another one that looked intimidating you wanted me to go over?
13.
Let's do 10. I heard 10 first. Solving for M. Let's get rid of what first? The 4. I don't want to circle the 4. I want to circle the M because that's what we're getting alone. But to do that, we're going to get the 4 out of there. So we have T over 4 equals the square root of M. I have a square root. Opposite operations are what I'm interested in. What am I going to do? Square it. Square both sides. Can't do something to one side of an equation without doing it to the other. All right? So these are opposite operations. The root and the power of 2, they cancel each other out. Just left with an M. The left-hand side, you actually square it. All right? So you take each part and raise it to the power. So T goes to the second power. So T to the second power, because I don't know what T is, over, then we do 4 to the second power, which is 16. Now we're not taking a root here, so I don't have to worry about plus or minus business or anything like that. Once I get M alone, I'm good to go. Did I hear 13?
Yes.
Okay. Oh, look at that baby. Oh, that's a nice looking formula. That's actually a geometry formula. Does anybody know what that's a formula for?
A sphere.
Well, area of a, not a sphere.
Of some sort of prism. Yeah,
Base
rectangular
1,
prism.
base 2.
No, if we're talking about rectangular prisms, we could be talking about area, but most likely we'd be talking about volume.
Those things like with it's like that.
You're absolutely right.
What is it?
Yeah, you're totally right.
Trapezoid?
Trapezoid, good stuff. Something like that. These are supposed to be parallel to one another, but I can't draw it. All right, start of the math class. What am I getting rid of first?
The half. The 1/2.
The 1/2. Let's get rid of that. Now we're trying to get B1 alone, so let me circle that. I want to get rid of the 1/2. How can I do that?
Multiply both sides by 2.
Multiply both sides by 2. On the right, it cancels with the 1/2. On the left, it just becomes 2a. So now I have h, then b1 plus b2. Now I want to do what? Get rid of the h, so let's divide it out. It's connected by multiplication, so it's disconnected by division. 2a over h equals a b1 plus b2. If you're careful and systematic about the way you do this, you're less likely to make a mistake. I think you're almost guaranteed to get it right. All right, just carefully, step by step. Final step? Subtract b sub 2. So I have 2a over h minus a separate, not part of the same fraction, minus a separate b sub 2 equals b sub 1. And we're looking for b sub 1. All right. Now, just in case they ask, we want to be prepared. H cannot be equal to what? 0. All right. Now, I would say, hopefully, once you learn the characteristics of some geometry formulas, hopefully that's common sense. Of course h is going to be not equal to 0. You're talking about a trapezoid, all right? The h, what do you think the h stands for? The height. If it's equal to 0, it's not a trapezoid, right? So it's this with no height. This line here would be on top of that other line. It's not a geometric figure. It's just another line, all right? So we know it would not be equal to 0, but also we would probably not want it to be what? Zero's out. We don't want it to be any negative numbers, right? Although later on in future courses you'll see that that's not as terrible of a thing as I'm making it out to be. All right. All right, we got time for one more. 14. Oh boy. This is extra crispy. This is definitely not original recipe. Close. A cone, exactly. Volume of a cone formula. Cylinder would be the same thing, just without the 1/3.
What is this? A sphere?
This is cylinder. It's cone. Volume of a cone. A sphere is 4/3 pi times the radius cubed. Multiply both sides by a 3 to get rid of the 1/3. So we have 3v equals it'd be nice if they asked for h. That would be really easy, one more step. But unfortunately they did not. What do I have to get rid of now? The pi, and also at the same time I could get rid of h. Meh, meh. Couple of mehs.
Then
Then I square root. Take the square root, it could be positive or negative, but it's going to be positive because why? Yeah, it's a geometry situation. We're looking at a volume, a radius, and a radius is most likely going to be a positive. So I'll write positive, negative, but then indicate that it's positive.
We have homework.
We do have homework. Sheets 35 to 37 in your packet, so anything that was not covered, we're going to do. So this relationship is such a time saver that it's incredibly worthwhile. If you don't want to know the shortcut, then you don't have to. I mean, you could always do things a long way, but that's your call. All right, so what I'm going to do is rewrite. I'm going to write it a little neater. The m over c, equals p minus 6 over 1. All right, so that's what the original question said, right? My answer, m over p minus 6 equals c over 1. So again, this is my question. This is my... Nah, we don't need an acronym. We need common sense more than anything else. All right, so let's see if we could figure this out. What is the difference between this and this? Don't use vocabulary, don't use math vocabulary. Just tell me how my purple proportion differs from my red one.
P minus 6 is swapped with C.
P minus 6 is swapped with C. That is the perfect way of saying it. All right? What that tells us is that we have a nice new relationship. It tells us that if you have diagonals within a proportion, you can always swap them. All right, so that looks like it went over half the room. So let's say I have this problem. 1 over x equals r plus s over t. And I need to solve for x. If I know this new rule that tells me that I can just swap diagonals wherever I want, I could just swap these two guys. So I'd have 1 over r plus s equals x over t. I could also swap these two guys and have t over r plus s equals x over 1, which is just the same as saying s.
You could do that with any, you could just swap.
You could swap them at the same time if you want.
So it has to be over 1 though? Does it matter?
Well, the final answer would be over x. I was just showing how it's still
You only
fraction.
can do that if there's a 1 in the problem.
Fraction equal fraction. It doesn't have to be 1, but they do have to be two fractions, two single fractions on either side. It's a life-changing event.
That is.
Can you help us with that?
Yeah. I'll get it. 1 second. I just want to get the recording stopped.